Let's explore the bulkhead pattern and the problem it aims to solve. Let's continue with our e-commerce microservices architecture. At the front, we have an API gateway that routes incoming requests to various services. This API gateway has a thread pool to handle user requests. It's important to note that this thread pool physically limits the number of concurrent users our system can manage. Now, let's consider a scenario where our payment service is experiencing issues and running very slowly. A user sends a payment request, which gets processed normally. Another user's shopping cart request is also handled without issues. An order tracking request comes in and is processed as expected. However, when another payment request comes in, it gets stuck waiting for a response from the slow product service. The same happens with yet another payment request. As more requests come in, they start to pile up. Eventually, our API gateway has to start rejecting requests because all threads are occupied. This continues, and more legitimate requests are rejected, even those for services that are functioning correctly. This scenario illustrates a critical vulnerability in our system. A problem in one service is causing a system-wide failure, affecting all our services. This is precisely the issue that the bulkhead pattern is designed to address. Now, let's see how the bulkhead pattern solves this problem. The key idea of the bulkhead pattern is to allocate a maximum number of threads to each service based on their forecasted load. This creates isolated pools of resources for each service. When a payment request comes in, it's allocated to the payment service's thread pool. A shopping cart request is handled by its dedicated pool. Similarly, an order tracking request goes to its own set of threads. Another payment request comes in and is processed normally. More payment requests arrive and are handled until we reach the maximum number of threads allocated for the payment service. This is where the magic of the bulkhead pattern becomes apparent. An order tracking request comes in, and despite the payment service being at capacity, it's processed normally because it has its own resource pool. Now, when another payment request arrives, it gets rejected because the payment service's thread pool is full. However, the system can provide a custom-prepared error response specific to the service experiencing an issue, improving the user experience. Meanwhile, an inventory service request comes in and is processed without any problems, unaffected by the issues in the payment service. This is the essence of the bulkhead pattern. By compartmentalizing resources, we prevent issues in one service from consuming all available resources and affecting the entire system. It's like the watertight compartments in a ship. Damage to one compartment doesn't sink the whole vessel. This approach significantly enhances the resilience and stability of our microservices architecture. Okay. That's all for today. Hit the like button. Subscribe, and I'll see you soon.